Hi, my name is Singwei Su, and I'm a software development engineer at AWS Elastic Container Service. And today we'll be talking about developing CI/CD pipelines with Amazon ECS and AWS Fargate. So why do we care about CI/CD with containers? The trend with modern applications over the past few years, as teams learn to scale their organization and services, has been to move away from one large monolithic application into smaller microservices that can be independently owned by smaller teams. Compared to traditional instance-based architectures, microservices that have a single self-contained function are easy to package as containers that can then be scaled independently on managed compute platforms. However, this does mean that there is now an explosion of the number of services that we need to deploy, and coordinating those deployments can be very time-consuming and error-prone. So for each group of microservices, you now need to set up quite a bit of infrastructure to ensure your various microservices are routing correctly to each other and that they're contained within the correct network boundaries and reachable by correctly configured endpoints. And this can be very time-consuming without a good CI/CD workflow. There's a lot of different choices when it comes to using CI/CD. Here at ECS, we've been working very closely with other popular tools to ensure that our customers can choose the one that best suits their deployment needs. There's different approaches to setting up your CI/CD workflows. The traditional approach is to provision your pipeline separately from your application and have your code flow through your various pipeline stages. Another approach is to define your pipeline infrastructure itself as code and have it deployed alongside your application. So we're actually going to take a look at both of these approaches using AWS Copilot and AWS Cloud Development Kit, or the CDK. So let's quickly look through what we generally want in a CI/CD pipeline. We usually have 4 types of stages: a source stage, a build stage, 1 or more test stages, and 1 or more production stages. The source stage is where you check in your source code and configuration files. Pushing code to this stage should automatically trigger a deployment through your pipeline. Next, we have the build stage, where the code pushed to the source stage is built or a container image is created. It's also good practice to run unit tests and maybe any style checkers in this stage. Test stages are where you actually deploy your application to an environment that resembles your production environment as closely as possible. This is where you can run integration tests to make sure your microservices are working end-to-end, run load tests, and other custom checks. And then finally, there's your prod stage, where you can set up monitoring and alarms to ensure your application is working as expected. So how do we provision all of this in a CI/CD pipeline using containers? So as mentioned previously, there's many tools for doing this, but today we're going to take a look at how to provision a CI/CD pipeline using AWS Code Pipeline. Code Pipeline allows for continuous delivery of your services for fast and reliable application updates. It models and visualizes your release processes. It can build, test, and deploy your code every time there's a code change. And it also offers many third-party integrations and AWS services, including Amazon ECS. So Code Pipeline allows you to use different integrations, as mentioned, for each of the release stages. So for example, in your source stage, you can use Code Commit or GitHub. And for your deployment stages, you can use AWS Code Deploy, CloudFormation, or Amazon ECS as your deployment controllers. When you're provisioning your pipeline, you want any pre-production stage to resemble production as closely as possible. So you may want to make sure that that is true for different environments in maybe different regions. And pretty soon you have a pretty involved pipeline with each stage requiring its own infrastructure and its own maintenance. So how do we do all of this with ECS? So let's talk about what all is even involved to deploy a containerized application using ECS. So the first thing you need is an ECS cluster. This is a boundary that defines all of the microservices in your application. Your cluster contains usually one VPC, which needs to be configured with a CIDR block. You'll also need to specify which availability zone you want your VPC to be in. And since it's good practice to not rely on a single AZ, you probably want to specify at least another one. Then in each availability zone, you'll need a private subnet and a public subnet, all of which need to hook into an internet gateway, and that's just for one stage. So for each of your stages, you'll need to provision and configure and maintain all of that infrastructure. And this is only the basic outline of what you need, because each resource, of course, has many configuration options. So that all seems pretty overwhelming. And if you didn't catch that all, that's okay, because we're going to talk about how to easily and quickly provision all of that infrastructure in a way that makes it really easy to stamp out copies of the same environment, since ensuring safe and dependable deployments for complicated microservice architecture makes having repeatable infrastructure really important. So first, let's take a look at AWS Copilot. Copilot's pipeline command follows best practices for setting up a CI/CD pipeline, automatically creating a source stage that is hooked into your GitHub repository and a build stage that leverages AWS Code Build. Both of these stages are created with minimal input from the user, so it's very easy to just follow best practices for two stages by default. You can then specify test and production stages based on the environments provisioned using Copilot's environment creation workflow, which automatically sets up all the resources mentioned earlier, such as VPCs, subnets, and so on, with same defaults. What this basically looks like is this. You would initialize your pipeline using pipeline init, and this will create a pipeline manifest file that is then used to generate a CloudFormation template that will create your code pipeline resource with the source, build, and however many deployment stages you specify. Here's an example of the pipeline manifest file. The source key allows you to specify parameters for your source stage, such as which branch you want to track and your GitHub repository name. And the stage key is where you specify which deployment stages you want to create. So this is best shown with a demo. So let's take a look at how the Copilot pipeline workflow works in action. So in this application, I have 3 different microservices, and they each exist in their own directory. So I can take a look here. I have an API, a backend service, a results service, and a vote service. And I've actually gone through the application init workflow with Copilot in advance. So I can just show you what exists already in this Copilot application by running Copilot app show. So here you can see I've got my services. I've got my 3 services that I mentioned before, the backend service and the 2 load balance web services. I have a couple environments set up, and I also have my 2 pipelines set up here, and they correspond to only 2 of my microservices. I don't have one set up yet for my vote service. So that's what we'll be trying to do today. So I can take a look at one of my existing pipelines. So here I'm in my results directory, and I can run Copilot Pipeline Show to get a bird's eye view of what this pipeline looks like. So I've got these 3 stages, a source, a build, and a deployment stage that corresponds to a test environment that I've already pre-provisioned. So I want this basic structure for my vote pipeline as well. So here I'm in my vote directory, and I can spin up a pipeline by saying Copilot Pipeline Init. It'll take me through an interactive workflow for adding environments to my pipeline as a deployment stage. So I would like to add an environment here. I have a selection of which environments to choose. I'm just going to do test for now. We're going to skip adding any other environments just for now. And next is setting up my source stage. So I want to hook in my GitHub repository. It asks me to create a secret here. So I have my personal access token. And that's it. That is what happens with pipeline init. I haven't actually deployed anything yet, so I'm going to do this real quick and let that run. And in the meantime, we can look at the files that were generated using pipeline init. So the first one is this pipeline manifest. As we can see, we have the source stage that was specified with my GitHub as a provider as GitHub, various properties here. I'm tracking my main branch, and there's my repository name. And here under the stages key, as you can see, I have the test environment specified as a deployment stage. I can also now look at the build spec file, which was also generated. And this is a pretty involved build spec file here, most of which you don't have to worry about at all. The important thing just to know is that this is what does create the container image and pushes that image to an ECR repository. Okay, so now let's take a look at our pipeline. So it's still going, and we can see, oh, there we go, it is created. So now we can take a look at this pipeline by running show again. And sure enough, there is my pipeline with the 3 stages that I specified. And that looks for my vote service, and that looks just like the one that I had for my results microservice. So that's it. That's all I needed to do to create that pipeline. And I'm going to run status real quick to see what that pipeline is doing right now. I can see that I've succeeded my source stage, and the build stage is currently in progress, and that happened just 33 seconds ago. So that's all there was to do. Very simple workflow to create a CI/CD pipeline for my ECS service. Now I can go and look at my application and show that again. Now I can see, sure enough, that pipeline for my vote microservice shows up there. And taking a look, we did mention that there was another environment besides test. We have this pre-prod environment. And I want to add this to my pipelines eventually. So let's go ahead and add this to an existing pipeline, the results pipeline. And all I have to do here is modify the manifest file. This is the pipeline manifest for my results pipeline. And all I have to do here is add the name of the stage. And then I can run Copilot pipeline update. And this will actually add that stage through another CloudFormation deployment. So now it is creating that new change set, and it will be deploying the new stage as part of my existing code pipeline resource. So we can take a look at this pipeline in the console for now. We can see that right now we just have that test environment as a deployment stage. It's still going currently. But we can see that going back really quickly to see what the vote app even does, since it's always important to know what you're voting for. We're voting for cats versus dogs. So of course they're going to vote for a dog. And here we go. This is the updated pipeline that has added the pre-prod stage to my results pipeline. So again, I can run pipeline show from Copilot, and I can see, sure enough, that this pre-prod deployment stage has been added. So with Copilot, it's very easy to modularly add stages to your release pipeline by modifying your pipeline manifest file to add or remove environments, to add test commands to run within each deployment stage, and so forth. Any changes to your pipeline manifest file require you to run pipeline update after any changes have occurred to ensure that infrastructure is modified. However, as we saw, sometimes we want to make sure that all of our microservices are being deployed to the same environments via CI/CD. With Copilot, each service has its own pipeline, and updates happen to each one independently and separately. So now we're going to take a look at coordinating those with infrastructure as code, where your pipeline and your application code are deployed together. So AWS, the CDK Pipelines, is a new higher level module in the CDK construct library that was released earlier this year. And these patterns take the approach of deploying your service code alongside your infrastructure code. So besides the traditional pipeline stages that we talked about earlier, CDK Pipelines adds 2 additional stages, an update pipeline stage and a publish assets stage. So the source stage is pretty much the same as what we saw before, with pushes to GitHub, triggering the pipeline, and the deployment stages are also using CloudFormation to deploy your applications themselves. The build stage, as with Copilot Pipelines, uses code build to compile code, but unlike Copilot Pipelines, the container images that are built are not yet pushed to ECR. This happens in a separate stage, publish assets, after any changes to the pipeline infrastructure itself are completed in the update pipeline stage. So again, this will be easier to see with a demo. So here we have a CDK project, and this repository contains infrastructure as code for my pipeline, as well as my code for my Fargate service. So this is what that pipeline code looks like. I have a stack here, and for sake of time, I'm going to go ahead and add this code change real quick and commit and deploy it just so that we can get it kicked off, and then we'll dive deep into the code. So here I'm adding a stage, and I'm going to push this to my GitHub repository because one of the things that's different between CDK pipelines and Copilot is that any changes to the infrastructure code does need to be in the GitHub repository. So this is what the deployed pipeline looks like. It was previously deployed, again, just to save time. We can see that in the source stage, the push that we just made has triggered the pipeline, and it's going through this pipeline. We've got this update pipeline stage, and then, again, very similar to the Copilot pipeline that we saw before. We have a deployment stage here, pre-prod, with a few stages within that stage. So let's take a look at this pipeline demo stack, a demo pipeline stack. So this is where we are creating the code pipeline resource. We're calling it my service pipeline. And we can specify the source stage, which is a GitHub stage with my repository name and so forth. My build stage is specified here. It's just a standard an npm build. And then this is where I actually add the application stages. And as you can see, we have this CDK Pipelines demo stage construct that's used. So let's take a look at that and see what that's about. So as you can see, it's just really a thin wrapper for another construct, the CDK Pipelines demo stack here, which is actually what is instantiating my web service, my Fargate web service. So now let's take a look at this code. So here, this is the stack that creates my application load balanced Fargate service. This comes from the ECS patterns module, which again is a really, really neat higher level ECS pattern, a CDK pattern that automatically spins up a Fargate service along with an ALB with minimal configuration. I just have to specify my container image here. And that's all I really need to have a fully functional Fargate service that's behind a load balancer, again, with all the same defaults created for you. We see here our deployment still hasn't quite succeeded. So it's still updating right now. But we can see through the ECS console that we do have those stages spun up here. So we have the clusters that correspond to those different environments. And here actually is the deployed Fargate service. If we check back now on the console for my service pipeline, we can now see that let's refresh our console real quick, and hopefully our new stage will be added. And yep, there it is. That's the staging stage that we just added from that initial Git push has been added to the pipeline. So that's it for the CDK Pipelines demo. As we saw, it was really easy to deploy a fully functional code pipeline resource with multiple stages added. All of that generates hundreds of lines of CloudFormation code with lots of configure options that you didn't have to write. With only a few lines of CDK code, it was really easy to provision a pipeline and ensure that each stage that you add are identical copies to existing pre-production or even production stages. So that's all for CI/CD pipelines using ECS and Fargate. I hope you enjoyed this talk, and make sure that you complete the session survey.